Hello everyone, Disha Kansara here, and my SEP ID is 600011980003. And today I'm going to explain the design circuit of adder circuit using opam in LT Spice. So first of all, I introduce the adder circuit and subtractor circuit. So this is my adder circuit. Yeah. So in this adder circuit, that produces an output which is equal to an sum of the applied inputs. And this section is discussed about the opam based on the adder circuit and adder opam based which is produce an output which is equal to sum of the input voltages and its inverting terminal. Then it is also called the summing amplifier since the output is amplified one. So the non-inverting summing amplifier is based around the configuration of non-inverting and operational amplifier circuit, and in that the input which either AC or DC is applied to the non-inverting terminal, while the required negative feedback is again achieved by the feedback some portion of the output signal V out, and yeah, the inverting terminal which is shown here. So the gain of the adder circuit which is 1 plus RA by R1. So this is my adder circuit, and now the subtractor one is the differential amplifier which amplifies the voltage differences present on these inverting and non-inverting inputs. The differential amplifier which amplifies the differences between the two voltages, making its type of operational amplifier circuit. And the subtractor, unlike a summing amplifier which adds or sum together the input voltages, if all the resistors are all of the same ohmic value, that uses a R1 which equal to R2 and equal to R3 and equal to R4, then the circuit will becomes a unity gain differential amplifier, and the voltage gain of the amplifier will be exactly 1 or unity. Then the output expression will be simply be the V out is equal to V2 minus V1. The differential amplifier circuit is very useful for op-amp circuit, and by adding more circuit in the parallel with the inputs of the resistors R1 and R3, so the resultant circuit can be made to either add or subtract the voltages applied to their respective inputs. So this is my subtractor circuit. Now I'm showing the calculations of adder circuit. So for the non-inverting adder, the output equation is given as a V out is equal to 1 plus RF upon R4 into V1 plus V2 plus V3 upon 3. And we have considered R1, R2, R3 is equal to R to make RF by R4 is equal to 2. So my RF is equal to 2 R4, and I assuming the RF is equal to R is equal to 10 kilo ohms. So the R4 is equal to RF by 2, which is 5 kilo ohms. So my R1 equal to R2 equal to R3 equal to R, which is 10 kilo ohms is shown here. Yeah, so I got the resistors value where I designed the circuit here, where I R1, R2 and R3 is 10 kilo ohms, and my RF is also 10 kilo ohms, and R4 is 5 kilo ohms. And to validate the result, I considered the three sets of input combinations, which is V1, V2 and V3. So I considered some voltages. So this is my theoretically calculation, and now I'm showing the practically circuit of one of the adder. So for that, click on a file and new schematic. To select any of the component, I select OP07, place over here. and I select the some resistors which placed over here, RF, R4, and 3 R1 and R2 and R3 resistors. So I placed all the resistors. To move any components, I select this. Yeah. So I move it all the components properly. Now I select the voltage source, select on component and click voltage source. So first of all, I give it the voltage source here plus and minus 15 volts for, and here the three input voltage source, and I given the ground. Yeah, so I'll connect with the wire all the components. And I given the V out here. My inverting terminal is grounded, and now I give the non-inverting terminal as the input. And connect the second resistor with the voltage source, and third resistor with the voltage source, and I'm connecting with the ground. So yeah, I also connect the VCC and VEE here, and I connect the voltage source with the wire. I'm giving the common ground between the two voltage source. So yeah, the circuit is ready now. Only I have to label to all the components. Here I'm going to label VCC. Here I'm going to label the VEE. Here VEE. Here I'm going to label V out. So now I'm going to label all my resistors value 10K, here 5K, 10K value, 10K value. And the last one is also 10K. So my negative feedback is I'm giving the label as RF. This is my R4, and this three resistor is my R1, R2, and R3. Yeah. So now this is my plus 15 volts, and this is my minus 15 volts. So now consider my validate result. I considered the three inputs, which is first V1, V2, V3 is 2 volt, 3 volt, and 5 volts. So I give this value over here, 2 volts, 3 and 5 volts. I slightly move it from here. Yeah, so my circuit of adder is ready. So now I'm going to simulate it. Click on DC output. Okay. So now just 1 second. Oh, sorry. Here is the 4 volt. I give it a 5 volt. by mistake. Yeah. So this is my output 8.99, which is approx 9 volts. This is my adder circuit. I theoretically calculate this as a 9 volts, and I got the value of a practical, which is 8.99. So this is my first adder circuit, and for the other two values, I already I already designed. So this is my second circuit where I applied V1. Yeah, no, sorry. This is my second circuit where V1, V2, and V3, which is 5 volt, 1 volt, and minus 6 volt. So my theoretical calculation, which is 0, and the practically output, which is minus 0.001, which is approx 0 volt. So this is my second adder circuit, and I also made the third circuit, which is where I given the input V1, V2, and V3, which is 1 volt, 3 volt, and 1 volts. So my theoretical calculation, which is 5 volts, and I got 4.99, which is approx 5 volts. So yeah, this is my calculation for the adder. So now I'm going to explain the subtractor circuit. So first of all, I like to explain you the calculations of the subtractor. So yeah, this is my subtractor calculations where VA, VB, the two input voltages to be subtracted where. So to design subtractors such that where the calculation equation is VO is equal to VA minus VB. So here V out equation is considered as V out is equal to 1 plus R4 by R1 and into R3 upon R2 plus R3 into VA minus R4 upon R1 into VB. So let the R1 is equal to R2 is equal to R3 is equal to R4 is equal to R is I considered as a 10 kilo ohms here, and the V out is equal to, so I put it the 10 kilo ohms for V1, R1, R2, R3, and R4, which is 1 plus 10k by 10k into 10k by 10 kilo ohms plus 10 kilo ohms into VA minus 10 kilo ohms upon 10 kilo ohms into VB. And so for that, my V out equation is proved. So V out is equal to VA minus VB. So I designed the subtractor circuit. So I get the value of R1, R2, and R3. And to validate the result, I considered the two sets of readings. Sorry. So VA and VB. So my theoretical calculations is I already calculate, and I already performed the subtractor circuit. Mm, yeah, this is my calculation. So I first of all I given the VA input, which is 2 volts, and VB is 3 volts. So I theoretically calculate minus 3 volts, and here is my circuit where I given V1 is 2 volt and V2 is 3 volt, and R1 is 10 kilo ohms, R2 is 10 kilo ohms, and R3 is 10 kilo ohms, and R4 is also 10 kilo ohms. So my practically calculation is minus 99.997 millivolts, which is approx minus 1 volts. So my first circuit already of the subtractor is already made, and the second one where I given the input of VA is 5 volts and VB 1 volts, and theoretic calculation which is 4 volts. So I already made this circuit also. So here I given V1 is 5 volt and V2 1 volt, and the resistors value is same for the 10 kilo ohms, and my output is 3.999, which is approx 4 volts. So yeah, my subtractor circuit is proved. So now I'm going to explain the linear equation calculation. So I already made this circuit. Yeah, so here I'm consider one equation where V out is equal to 2 VA plus 3 VB minus 4 VC, and I make a one observation table where VA, VB, and VC I considered the three sets of readings, where first reading of VA, VB, and VC is 1 volt, 1 volt, and 1 volt. And I theoretically calculate the V out is 1 volt, and my equation is this. So now I'm going to show you the first circuit, schematic circuit, which is my V out equation is this, and I used our OP7 two OP707, where my RF1, which is 10 kilo ohms. I assume RF is 10 kilo ohms, both of the RF. So I make here RF is 10 kilo ohms, R1 and RF. I show you the calculations of linear equations. Yeah. So my V out equation first is RF by R1 into VA plus RF by R2 into VB plus RF by R3 into EC. So my V out is 2 VA plus 3 VB minus 4 AC. So I assume RF is equal to 10 kilo ohms, where RF by R1 is 2. So my R1, I get the value of R1 5 kilo ohms, and like that I get the value of R2 and R3, which is 3.3 kilo ohms and 2.5 kilo ohms. So yeah, this is my calculation of theoretically and practically. So I shown the schematic first. Yeah, so this is my output of the practically circuit, which is 1.305 volts, where I theoretically calculate 1 volt, which is approximately 1 volts. For the second one, second equations, where my input I given the V1 is 2 volts, V2 is 1 volt, and V3 is 2 volts. So this is my second circuit of linear equation, where I theoretic calculations is got the 2 volts, minus 1 volts, and I got the output over here is 60.5400 millivolts, which is approx the minus 1 volts. So yeah, this is my second circuit, and the third one, which is last one circuit equation, where I given the input V1, V2, and V3. V1 is 5 volt, V2 is 1 volt, and V3 is 2 volt, and all other resistors value is same. So I got the output of practically is 5.9688, and theoretically I got the calculation is 5 volts. So yeah, thank you.